A lot of advances in science build on decades of curiosity-driven experimentation by people that just have a passion for understanding nature, said Professor Jennifer Doudna, chemistry Nobel winner in 2020. Hello everyone, my name is Emad Hushmand and I recently got a PhD in organic chemistry and completed 2 postdoctoral courses. Everyone knows that understanding nature was a key part of making many important scientific discoveries that change our world in big ways. As it turns out, there are many examples in the history of science of how focusing on nature leads to discovering novel and useful materials and molecules. In this podcast, I would like to briefly talk about one of my research areas in 3 episodes: fusion of cellulose and multi-component reactions, benign by design. Firstly, I want to talk about benign by design. Benign by design metaphorically means kill 2 birds with 1 stone. Benign by design is a term used to describe products, systems, or processes that are intentionally designed to minimize harm or negative impacts on people and the environment. To make the story very short, design a sustainable strategy for a green product. Episode 2, cellulose. You have probably come across cellulose these days. For example, cellulose cups for drinking coffee or tea. Cellulose is introduced as a remarkable and promising biomaterial for widespread application, which is obtained from bio-based sources such as plants, biomass, or bacteria. Cellulose with renewability, a highly ordered structure, non-toxicity, biodegradability, high availability in nature, and high thermal stability is a highly prominent biomass component for industrial applications such as the plastics and polymer industry. This biopolymer has versatile uses in many industries such as veterinary, foods, wood and paper, fibers and clothes, cosmetic and pharmaceutical industries as excipient, packaging, healthcare materials, electronics, battery and printing, and so on. However, this biomass material has suffered from several drawbacks, including low solubility and lack of thermoplasticity. To overcome these limitations, modification and functionalization of cellulose to obtain novel materials with various properties and applications are highly recommended. The functionalization of cellulose creates special properties, especially for the fact that this functionalized cellulose can be used for different purposes. In this regard, ring opening polymerization, alkoxycarbonylation, succinylation, esterification are some common strategies. Final episode, multi-component reactions or MCR. MCR are one-pot types of reaction made from 3 or more substrates, which can lead to direct access to target products with molecular diversity and atom economy. Historically, traditional stop-and-go synthesis is composed of the reaction step, separation, isolation, and purification. Alternatively, one-pot MCR synthetic route refers to chemical reaction conducted in a single reaction vessel. Therefore, a one-pot MCR synthetic route can lead to remarkable efficiencies as well as limited waste. From a green chemistry point of view, decreasing the number of steps and limiting the reaction to just one reaction vessel can be considered a major advantage. More importantly, intermediate steps are generated in situ without necessary purification in MCRs, which supports the green approach. Granted that organic transformation can be more efficient if toxic or reactive reactants are quickly consumed and do not significantly accumulate in the process. Consequently, MCRs for the functionalization of cellulose are more practical than a stepwise synthesis requiring activation steps, tedious workup, harsh conditions, and complex solubilization approaches. Since aldehyde functional groups exist in most of the MCR strategies as an integral component, Dialdehyde cellulose, which is directly prepared via the oxidation of cellulose derivatives, could play a key role as an effective component in MCRs. MCR are generally carried out in eco-friendly media such as water without any catalyst or high temperature, which could make them both academically and industrially more practical for the modification of cellulose. As a matter of fact, dialdehyde cellulose has the appropriate solubility in water, which means that many MCRs like Pastorini, Ugi, and so on can be successfully conducted in water as the greenest solvent. As a result, modification of cellulose is performed via a one-pot sustainable synthetic route in eco-friendly conditions. These cellulose-based MCRs lead to materials that exhibited new properties suitable for applications ranging from drug delivery and catalysis to emulsifiers and more. There are plenty of opportunities to further enhance the fusion of cellulose and MCRs in a more efficient manner that can be conducted in the near future. Thank you for listening to this podcast. I hope it is useful for you. For more information in this scientific area, you could read my articles. Have a good time. Bye.